just want to give a bit of perspective before I get into this talk. So I spent a lot of my career working on the hardware side of things. I spent about 17 years at Qualcomm Research. And for the last couple of years, I've been trying to don a software hat, kind of see, what is it that these software guys do that's harder than what we spend years making chips. So talk about quantization. It's an interesting kind of mix of software and hardware. And there's one thing I want you to kind of take away from this talk. It is to kind of not ignore some of the software challenges of doing it. Because the world looks very different when you're a user of a chip rather than the designer of a chip. And which is what, say, once you go to the other side, once you work for companies like Google or Facebook, that's kind of what you see. That gets started. So a lot of this work is really a summary of the work that I did when I was at Google and more recently at Facebook. I want to acknowledge the contributions of several colleagues here. And with that, I'll just get started. I know it's another audience, but just want to give you a sense of, why is quantization considered really important at, companies that really have large cloud infrastructure. And this is kind of the number one reason. So they're building data centers, their user base is growing, but the power consumption just keeps increasing every year. And that becomes a big challenge when you build a data center. And why is it important if you are looking at the edge? By edge, I'm including from mobile devices to much low power applications here. The number of edge devices is going up, and a lot of these devices, you want them to be smart, you want them to do some computer vision or some machine learning, and they are really resource constrained. On top of that, if you kind of look at this complexity versus accuracy trade-off, just for classification, right? If you just look at different models, ignore the VGG models, I think they're kind of older models, they're the models that came out earlier. Just look at this comparison, you sort of see that it's, you have to spend a lot to get a small improvement in accuracy. And keep this in the back of your mind when you sort of look at the results of quantization. So the main thing here is that to go from, say, 75% accuracy to 80% accuracy, you really are going from, say, 5 to 10 gigaflops all the way to like 20, 25. So we're really talking about a quantum increase in the amount of complexity that you have to take.